Watching channel Maths and Maths Academy. In this video we are going to learn how to find inverse, adjoint and determinant of a 3 by 3 matrix. So let's get on with our solution. The given matrix is A is equal to, the first row is 1, 2, 3, second is 0, 1, 5, and the third one is 5, 6, 0, and we are going to find here A inverse, which is equal to 1 over determinant of A multiplied by adjoint of A. So we have to find all the three, that is A inverse, determinant of A and adjoint of A. So let's go ahead with the determinant first. Determinant of A is equal to, first we will write 1 and then we will take it as a small determinant of 2 by 2 and write it here like we will multiply 1 with 0 and we will subtract product of 6 and 5 from that. So how we do it? 1 into this we will multiply with this, 1 into 0 minus this we will multiply with this, 5 into 6, then we will take the second entry of the first row, which is 2, we will write here minus 2, multiply by, we will multiply these two, 0 into 0 minus, we will multiply this with this, so 5 into 5, okay. Now we go to the third one, plus 3 into 0 into 6 minus 1 into 5. Now we will solve it. Is equal to 1 into 0 minus 30 minus 2 into 0 minus 25 plus 3 into 0 minus 5. So 0 minus 30 is minus 30, multiplied by 1 is minus 30. 0 minus 25 is minus 25, multiplied by minus 2 is plus 50. 0 minus 5 is minus 5, multiplied by 3 is minus 15. So the answer is equal to 5, which is not equal to 0. It means it shows that A inverse exists. If this value was equal to 0, then when we cannot calculate the inverse of A, which means it does not exist. So since it is not equal to 0, so it exists and we can calculate it. So now let us calculate the adjoint of A. We first find the matrix of cofactors of each of the elements, then take the transpose of that matrix. Let us write down one more time our matrix so that it should be easy to understand. 0, sorry, it is 1 2 3 0 1 5 5 6 0. Let us denote the positions of its entries as, like we write the positions of its entries as A11. First one represents row, second one represents column. First row, second column, first row, third column. Second row, first column, second row, second column. Second row, third column, third row, first column. Third row, second column, third row, third column. These corresponds to these. So 1 is equal to A11, 2 is equal to A12, 3 is equal to A13. This we are doing for the sake of understanding. Now we will find the cofactors. What is A11? Is equal to 1. As you can see, this is A11 equal to 1. Cofactor is equal to, how we do it, we will write -1, and here we will write the sum of the row and column position of that entry. So here, since it is 1 1, so we are writing 1 plus 1 here, and multiply by into what we will do in this case. We will multiply 1 with 0 and subtract the product of these two. So 1 into 0 minus 5 into 6 equals, or let us write it opposite to that, otherwise it will become too big, is equal to -1 raised to power 2 is +1. 1 into 0 is 0 minus 30 is equal to -30. So this is the cofactor of A11. Now we go to A12. What is A12? A12 is equal to 2. So cofactor is equal to -1 raised to power 1 plus 2. This is the one from where we are getting it, into 0 into 0. This 0 with this 0, and then this 5 with this 5. 5 into 5 equals -1 raised to power 3 is -1 into 0 minus 25 is equal to -25 multiplied by -1 is 25. Now we go to A13. What is A13? A13 is equal to 3. Its cofactor is equal to -1 raised to power 1 plus 3 into 0 into 6 minus 1 into 5 is equal to minus 1 raised to power 1 plus 3 is positive 1, so no need to write. 0 into 6 0 minus 5 is equal to minus 5. Now we go to a to 1, which is equal to 0. So cofactor is equal to minus 1 raised to power 2 plus 1 into 2 into 0 minus 3 into 6. Let's solve it. Minus 1 raised to power 3 is minus 1 into 0 minus 18. Minus 18 multiplied by 1 is plus 18. Then we go to a22. a22 is equal to 1. So cofactor is equal to minus 1 raised to power 2 plus 2 into 1 into 0 minus 3 into 5 minus 1 raised to power 4 is plus 1. 0 into 1 is 0, 5 into 3 is 15. So minus 15 into 1 is minus 15. Then comes a23. a23 is equal to 5. So cofactor is equal to minus 1 raised to power 2 plus 3 is equal to minus 1 raised to power 2 plus 3 into 1 into 6 minus 2 into 5 equal to minus 1 into 6 minus 10. 6 minus 10 is minus 4. Minus 4 multiplied by 1 is plus 4. Then we go to a31. What is a31? It is 5 again. So cofactor is equal to minus 1 raised to power 3 plus 1 into 2 into 5 minus 3 into 1 is equal to minus 1 raised to power 4 is plus 1 into 2 into 5 10 minus 3 10 minus 3 7. 7 multiplied by 1 is 7. Then comes a32. a32 is equal to 6. So cofactor is equal to minus 1 raised to power 3 plus 2 into 1 into 5 minus 3 into 0 minus 1 raised to power 5 is minus 1. 1 into 5 is 5 minus 0. Five minus 0 is 5 into minus 1 is minus 5. Then the last one A 3 3 is equal to 0. So cofactor is equal to minus 1 raised to power 3 plus 3 into 1 into 1 minus 2 into 0 is equal to minus 1 raised to power 6 is plus 1. 1 into 1 is 1 minus 0. 1 minus 0 1. 1 into 1 is equal to 1. So the adjoint of A in this case is equal to, now we will write all the cofactors, which are minus 30, 25, minus 5, 18, minus 15, 4, 7, minus 5 and 1, and we have to take transpose of this. So what is transpose? We have to make the rows as columns to convert a matrix into its transpose. So minus 30, 25, minus 1 is the first row, we will make it a column. Minus 30, 25, minus 5. Then we will do the same with the second row, we will make the second column. And with the third one, 7, minus 5 and 1. So this is the adjoint of A. Now we are going to find inverse of A, which is 1 over determinant of A into adjoint of A. 1 over, what was the determinant we have calculated? The value of the determinant was 5. So we will write 5 over here. Now let's write the adjoint of A, which is minus 30, 18, 7, 25, minus 15, minus 5, minus 5, 4 and 1. Let's multiply 1 over 5 with all the entries of this matrix. So the matrix will become like minus 6, 18 over 5, 7 over 5, 5, minus 3, minus 1, minus 1, 4 over 5 and 1 over 5. So this is the inverse of the matrix. So we have found all the required answers, like we have found determinant, we have found adjoint of A, and we have found inverse of A. Now we will check we will show here that A multiplied by A inverse is equal to unit matrix of 3 by 3 order. Like we will say A multiplied by A minus 1 is equal to I. So what is A in this case? Let us write A dot A minus 1 is equal to, A multiplied by A minus 1 is equal to, what is A? 1 2 3 0 1 5 and 5 6 0. This one is minus 6, 18 over 5, 7 over 5, 5 minus 3 minus 1 minus 1, 4 over 5 and 1 over 5. Now what we have to do, we have to multiply this row with this column first, then with this column, and then with this column. So when we do that, we will be getting minus 6 plus 10 minus 3, 18 over 5 minus 6 plus 12 over 5, then 7 over 5 minus 2 plus 3 over 5, then we will go to the second row, this one, this is the second row, and we will multiply with all the three columns, and we will write 0 plus 5 minus 5, 0 minus 3 plus 4, 0 minus 1 plus 1. Then we will multiply the third row with all the three columns one by one. We will have minus 30 plus 30 plus 0, 18 minus 18 plus 0, 7 minus 6 plus 0. Okay, it is equal to 6 minus 3 is minus 9 plus 10 is 1. Then the next one comes 0, then 0, then 0, then 1, then 0, then 0, then 0 and 1, which is equal to unit matrix I, and that is what we are looking for. That's all for now. If you like this video, then please subscribe this channel. Until the next time, take care and bye.